Here we are on page 13 of sequences and series. A geometric series is the blank of the terms of a geometric sequence. So remember that a series is a sequence with addition in it. So when you add all the terms together in a sequence, you're talking about a series. So it's the sum of the terms of a geometric sequence. What is R and U1 for the series above? Well, remember that U1 is the first term, so it's just 1. And R is the multiplier, so to go from one term to another, we're always multiplying by 2, so R is 2. Common ratio starts with an R. So what is N? Okay, so how many times, let's see, UN equals 1024, it's equal to 1 times 2 to the n minus 1. Well, from past experience, I know that 2 to the 10th is 1024, so that means n is equal to 11, right? Okay. For a finite geometric series with r not equal to 1, we're given two formulas to figure out the sum of a geometric series. And remember the video that you watched right after the last investigation, where you learned about how this is derived. Now use each of the two formulas above to calculate S sub n for the series above. Okay, so first we're going to use this one, and so it'll be 1 times 2 to the nth, the n is 11, minus 1, divided by 2 minus 1. And the other possibility is this one, so it'll be 1, and I'm just going to erase this, times 1 minus 2 to the 11th over 1 minus 2. So this is going to give us 2 to the 11th is 2048. So 2048 minus 1 would be 2047 divided by 1. And this one would be negative 2047 divided by negative 1. So you can see that they both work out to be positive 2047 regardless of which one you use. So although they look different, they're actually the same formula. Okay, just one is the negative of the other on the numerator and the denominator. Okay, so now there's two examples in the book. And then let's say we're going to do A and C. Find the sum of the following series, 12 plus 6 plus 3 plus 1.5, up to 10 terms. So we know that n is 10, and we know that u1 is 12, and we know that r is equal to 1/2, right? Because each one is a half of the previous one. So we could use either one of these formulas. So we can write S10, S sub 10 equals u1, which is 12, r, which is 0.5, to the 10th minus 1 over 0.5 minus 1. Okay, and then we could use our calculator to figure out what that's equal to. It would be 0.5 to the 10th minus 1 times 12 divided by negative 0.5. 23.976, which would be 0.98, 23.98. Okay. What about this one? This would be S sub 15 equals, first term is 6, the multiplier is negative 0.5, right? Because 6 times negative 0.5 would be negative 3. And that would be to the 15th minus 1 over negative 0.5 minus 1. So that would be equal to negative 0.5 to the 15th minus 1. Oops. Minus 1. You have to be really careful about parentheses on these, which is the reason why I kind of do everything in PEMDAS order, because if I don't, or if I don't do it like this, if I do it all at once, I'm going to have to put a lot of parentheses in there. Okay, so the answer for this one is negative 4. Okay. We're going to do AC here. Find a formula for S sub m for the first n terms of the series. So for A, the u1 is equal to square root of 3. And the r is also equal to square root of 3. So we could write the formula here. Square root of 3 to the nth minus 1. Square root of 3 to the nth minus 1 divided by square root of 3 minus 1. Okay, so that's the answer for A, because it just says find the formula for the first n. Okay. Next one, we know that u1 equals 0.9. We know that r is equal to 0.01. Is that right? No, it's 0.1, right? 0.1. Because when we multiply the previous number by 0.1, it moves the decimal point over 1. So 0.9 times 0.1 is equal to 0.09. If you wanted to figure that out, you could just do, okay, what's r? Well, you know that 0.09 is equal to u1 times r, which is equal to 0.9 times r. So r is equal to 0.09 divided by 0.9. And if you do that on your calculator, you'll see that that's equal to 0.1. Okay? Alright, so let's put all the data in. So u1 is 0.9. And then the r value is 0.1. And the r value, again, is 0.1 here. Okay? So that is the formula for S sub n. Alright. A geometric sequence has partial sums. S sub 1 equals 3 and S sub 2 equals 4. State the first term u1. Well, S sub 1 is equal to u1 plus nothing. So S1 equals u1. So we know that u1 is equal to 3. Right? S sub 2, so that's the answer for A, by the way. So B, calculate the common ratio. Well, we know that S sub 2 is equal to u1 plus u2. So we know that S sub 2 equals 4, we know that u1 is 3, and we just don't know what u2 is. Well, u2 is obviously 1. Okay, so that's B. Now it says calculate the fifth term of the series. So that would be, calculate the fifth term of the series. So that's just u5 equals u1 r to the n minus 1. And of course, n minus 1 for u5 is equal to 4. So it's 3 times r. Oops, I forgot to do r here. u2 is equal to u1 times r, right? So r is equal to u2 divided by u1, and u2 is 1, u1 is 3. So r equals 1/3. So we can put here 1/3 to the 4th. Okay, so this is actually equal to 1/3 to the third, which is equal to 1/27. Okay? All right. Number 4. We're going to do A and C. Evaluate these geometric series. We're going to use the calculator to do this. Unless this is yeah, I think we should use the calculator for this. Okay. So actually, we can simplify this because remember, we can put the coefficient out front. So this is actually equal to 3 times the summation of 1 through 10 of 2 to the k minus 1. Okay. Actually, I think we don't need to use the calculator for this. What we could do is we could use the formula. So we'll have equals to 3, and then we'll put the result of the formula in here. The formula, remember, is u1 times 1 minus r to the n divided by 1 minus r. So for u1, we could put in, and remember, we're just looking at this part here. So the u1 would be 2 to the 0, which is 1. Okay? And then r is equal to 2. We'll put 2 here and 2 here. And n is the 10th, right? Because it goes from 1 through 10. Okay, so we know that n equals 10, we know that r equals 2, and we know that u1 equals 1, and that's how we filled in that formula. So now we could simplify it. On the bottom we have -1, and on the top we have 1 minus 2 to the 10th. Remember that 2 to the 10th is 1024. We saw that above. So actually that's 3 times 1023. Okay, so that is the result for A. Let's see, B. So B, let's see, it's 6 times the summation of this one. So u1 would be equal to -2. R would also be equal to -2. And n would be equal to 25. Right? Okay. So now let's fill in the formula. So u1 is -2. We would do 1 minus -2 to the 25th. And on the bottom we would have 1 minus a -2. So that would be equal to 6. And on the numerator we would have -2 to the 25th. So 2 to the 25th. So that it would actually be negative of that. So negative second answer. Okay, so that's this part here. And then actually we take the negative of that and we add it to 1. So we take the negative of that, add 1. Okay, and then we'll get this part, yeah, that's that part, and then we're going to multiply that by -2. So multiply that by -2. Okay, so the top part is going to be that huge number. It's going to be -67108866. And the bottom is going to be 1 plus 2, which is 3. Okay, so we're going to divide that by 3. And then we're going to multiply that by 6. And that'll give us that huge number. Negative 134,217,732. Okay? All right. Number 5. Each year, a salesperson is paid a bonus of $2,000, which is banked into the same account. It earns a fixed rate of interest, 6% per annum, with interest being paid annually. The total amount in the account at the end of the year is calculated as follows. Okay, so at the very beginning, he has $2,000, which he earned that year. And then after 1 year, he has an additional $2,000, plus he has the original amount times 1.06 because he earned 6% interest on top of what he had. Now the following year, the same thing happens. He adds 2,000 more, and he multiplies what he had before by 1.06. Okay, so it says show that A2 is equal to this expression here. So we can get that by saying, oh, well, A2 is equal to 1.06 A1 plus 2,000. But A1 is equal to, and we have it here, is equal to 1.06 A1 plus 2,000. So do you see how A2 is actually equal to 1.06 squared A1, or A0, plus 2,000 times 1.06 plus 2,000. So we've already shown that. Okay, and now to show A3, it's the same thing. You would just repeat that, except for A3 is equal to 1.06 A2 plus 2,000. So you would just substitute this A2 into there, and then you could get what they have here. Okay, find the total bank balance after 10 years, assuming there are no fees and withdrawals. Okay, so basically I think this would be easy if we just extended the pattern here. So if it was a sub 10, we know that that's equal to 2,000 times, and then we would have 1 plus 1.06 plus 1.06 squared plus, and we would go on until we get to 1.06 to the 10th. Right? Okay, and then the thing is, we know how to calculate the sum of this because this is a geometric series, right? So we could put that U1 is equal to 1, R is equal to 1.06, N is equal to 11, right? Because there's 11 terms here. And then we're going to find the sum of that. So the sum is equal to 1 times 1 minus R, 1.06, to the n, which is the 11, divided by 1 minus 1.06. Okay, so that's how you get this part here. So this is equal to that. Okay, and then you would just multiply by 2,000. All right. Okay, so we have this geometric series now, 1/2, then 1/4, plus 1/8, 1/16, all the way to 1 over to the nth. Find each one of these sums in fractional form. Okay, so S sub 1 would be equal to just the first term by itself. S sub 2 would be equal to the first two terms, which is equal to 3/4, right? S sub 3 would be equal to the first three terms, which would be equal to it would be equal to 4/8 plus 2/8 plus 1/8, that'd be 7/8, right? S sub 4 would be equal to 15/16. And S sub 5 would be equal to 31/32. Okay? From A, guess the formula for S sub n. Okay, let's try that. S sub n would be equal to, let's see, we could say that this is 2 to the first over 1. This is equal to 2 to the second over 2 to the second minus 1. maybe that's the form. So it's 2 to the 5th over 2 to the 5th minus 1. Okay, so let's try that. So we'll have 2 to the n, and at the top we'll have 2 to the n minus 1. That'll be our formula. Okay. Okay, and then find s sub n using this. So let's see. u1 is equal to the first term, which is 1/2. r is equal to 1/2. N, we don't need to specify. So we have s sub n equals 1/2 times 1 minus 1/2 to the n divided by 1 minus 1/2. 1 minus 1/2 is 1/2, so that would cancel out with that. And we're left with 1 minus 1/2 to the n. Okay, and I think that would be the same thing as what we have here. All right. Comment on s sub n as n gets very large. So as n gets very large, this term here, this yellow term, is going to get very small, because if you multiply 1/2 times itself a bunch of times, it just gets closer and closer to 0. So basically, s sub n, as n gets very large, approaches 1. Okay, the whole thing approaches 1. What is the relationship between the given diagram and D? So if you look at this, this is a square, and they just cut it up into 2 halves. And then they cut that half into 2 halves. And then they cut that half into 2 halves. And they just keep doing that. And as you can see, if you look at the fractions of each of these, it follows the geometric series formula right there, right? So you can see that if you just keep cutting each half into a half here, you're never going to get bigger than the square, right? You're going to approach the square. Pretty soon you're going to be snipping a very small rectangle, but you're never going to, the sum total of all the fractions is not going to be bigger than the square. And so that is the relationship between the diagram and D, because you can see D never, D never exceeds 1. This square is never going to be exceeded either. Okay?